Let's look at how to do squaring binomials as well as difference of squares. So we're going to start with difference of squares. And here we have x minus 3 times the quantity of x plus 3. So if we use FOIL, okay, for first, right here, outer and inner, and then this is our last, we're going to get x squared, x times x. The outer term is x times 3 for 3x. Our inner term is negative 3 times x for negative 3x. And our last term is negative 3 times negative 3 for negative 9. When you combine 3x minus 3x, these are going to cancel out, and your answer here is x squared minus 9. So it's this term minus this term squared. So x squared, this term squared, minus this term squared. If we were to look at that rule, we should get here 2x squared, right, is, so we're going to say minus 5 squared. So our answer should be 4x squared minus 25. Let's look at this rule using FOIL to see if this is going to give us that answer. 2x times 2x, okay, is 4x squared. So that's our first. Our outer terms is 2x times 5, which is 10x. Our inner term is negative 5 times 2x, which is negative 10x. And our last term is negative 5 times 5, which is negative 25. These will cancel out, and when we simplify this, we will get the answer of 4x squared minus 25. Alright, so that is difference of squares. When we look at squaring a binomial, we actually have a rule here. Okay, for this one, since this is negative, we can say x squared minus 2xn plus n squared. Where with this, okay, our x term is 3x and our n is negative 4. So if when we apply this rule, x squared is 9x squared, okay, because 3x squared, 3x times 3x is 9x squared, minus 2 times 3x, which is 6x, and then times negative 4. Okay, so we're going to be saying, or this is actually 4 here, so we're going to say minus 6x times 4, so that's going to be negative 24x. And then our n term is plus 16. Let's look at this using FOIL. If we use our FOIL, just as another way to check it in case you're not totally convinced that that rule works, and that's perfectly fine. I still go back to FOIL. Memorizing those rules didn't work for me. So 3x times 3x is 9x squared. The outer term is 3x, because this is the same as saying 3x minus 4 times 3x minus 4. Okay, so we have our first and then our outer. So that is 3x times negative 4, which is negative 12x. The inner term is that, just using the commutative property. So, and then our last terms is negative 4 times negative 4, which is 16. When this is all combined, get 9x squared minus 12x plus 16. This does not cancel out because it's not minus 12 plus 12. So it's negative 12x minus 9x squared minus 24x plus 16. Now for the very last one, we also have an example of squaring a binomial. However, this time it's a little bit different in the sense that it's x squared plus 2xn plus n. That is because this term is being added here, not subtracted. So if we use the same rule here with our x term here, our x term is 3x and our n term is 1. So using this, when you use this rule, you're going to get, let's put this in different color. So 3x squared is, or 3x and squaring that is 9x squared. 2 times 3x is 6x times 1. So you're going to get plus 6x. And then 1 squared is 1. If you want to check this using FOIL, okay, this is the same as saying 3x plus 1 and then times the quantity of 3x plus 1. So then 3x times 3x is 9x squared. The outer term is 3x times 1. The inner term is 1 times 3x. And then the last terms are 1 times 1. Combining this, you get 9x squared plus 3x plus 3x plus 1. Combine the like terms to get 9x squared plus 6x plus 1. And that is another example for squaring a binomial. Like always, if you have any questions, please let me know. Good luck.